The topic of this video is finding the horizontal or oblique asymptote of a rational function. Let's look at a problem. Find the horizontal or oblique asymptote, if any, of the rational function q of x equals, the numerator is x cubed minus 27, and the denominator is x squared plus x minus 12. Okay, so the steps are determine the degree of the numerator and the degree of the denominator and compare them, then take one of 4 actions. Let's begin this process now. We notice that both our numerator and denominator polynomials are written in standard form, and therefore the degree of those polynomials comes from the highest exponent of x needed to write the polynomial. Therefore, our numerator has degree 3, our denominator has degree 2. Now we compare them. We find that the numerator degree is bigger than the denominator degree. When that happens, we have to ask ourselves, by how much? 3 is more than 2 by 1. This is case C from our 4 possible outcomes. Let's read it together. If the degree of the numerator polynomial is 1 higher than the degree of the denominator polynomial, then use polynomial long division. If there is a remainder, then the quotient discarding the remainder will be the equation of the oblique asymptote. Okay, so we now need to perform polynomial long division. Let's go ahead and set up our problem. When setting up a polynomial long division problem, the first thing you need to remember is that the numerator goes underneath your division bar and must include all term types that you could have while solving the problem. For example, we have an x cubed, but we don't have any x squared or x terms, so we need to leave space for those. We give them a coefficient of 0. So we're going to write x cubed minus 27 as x cubed plus 0x squared plus 0x minus 27. Our denominator will go outside the division bar, x squared plus x minus 12. It is very wise to create columns where all of our terms will go while performing the polynomial long division. So just to the left of each add or subtract sign, we're going to put a vertical line. This creates our columns. The first column for this problem will be the x cubed column, working from left to right, then the x squared column, then the x column, then the number column. As we fill in our polynomial long division, we'll place each term in the appropriate column based on the type of x term we have. Okay, so now we're ready to go through the steps for polynomial long division. The first step is to take the first term of the lowest under and divide it by the first term of the denominator. We'll do that in our side workspace. So we have x cubed divided by x squared. This gives us the result x, which is the first piece of our quotient. That means it goes above the division bar in the appropriate column. The exponent of x is 1, so it goes in this column, the x column. Next, take the newest piece of your quotient and multiply it by your entire denominator. Using the distributive property, this will give us x cubed plus x squared minus 12x, which is placed beneath the lowest under in the appropriate columns. So the x cubed goes in the x cubed column, the x squared goes in the x squared column, and the minus 12x goes in the x column. Next, perform the rhyme, which says, draw the line, change the sign, then combine. So, we will draw the line underneath each of the new terms we just added to our problem. We will change the sign of each of those terms. So this positive becomes negative, this addition becomes subtraction, this subtraction becomes addition, and then we will combine each of those terms vertically. x cubed and negative x cubed combine to make 0. 0x squared minus 1x squared makes negative 1x squared. 0x plus 12x makes plus 12x. I will now bring down all terms from my original that have not yet been revised. Now I will compare the highest exponent of the lowest under with the highest exponent of my denominator. I will stop my polynomial long division when this number, the highest exponent of the lowest under, is less than the highest exponent of my denominator. So is 2 less than 2? No, therefore I will continue the polynomial long division process, and I go back to the beginning. So, first term of the lowest under divided by first term of the denominator. Once again, I'll use my side workspace, so I have negative x squared divided by x squared, which gives the result negative 1. This is the second piece of the quotient. Therefore, it goes above the division bar in the appropriate column. This is just a number, so it goes in the number column. Next, we use this most recent addition to our quotient to multiply by the entire denominator. And once again, use the distributive property, this time getting negative 1x squared minus 1x plus 12. This is placed beneath the lowest under in the appropriate column. The minus 1x squared is going to go in the x squared column. The minus 1x is going to go in the x column. The plus 12 will go in the number column. Next, draw the line, change the sign, then combine. Let's do that. Draw the line, change the sign, then combine. Alright, the highest exponent of our lowest under is 1, which finally is less than the highest exponent of our original denominator. So we are now done with the polynomial long division process. The 13x minus 39 is our remainder. And the x minus 1 is our quotient. We are now ready to state our conclusion for this problem. Let's remind ourselves one more time what case C says. If the degree of the numerator polynomial is 1 higher than the degree of the denominator polynomial, then use polynomial long division, which we have done. If there is a remainder, then the quotient discarding the remainder will be the equation of the oblique asymptote. So, did we get a remainder for this problem? The answer is yes. Therefore, we will have an oblique asymptote, and its equation will be y equals the quotient x minus 1. This completes our problem.